Hello, everyone, and welcome to the Impractical Machinist podcast. My name is Patrick, and you can find me on Instagram as @JobShopperTM.
I'm Cameron from Machining is Cool.
I'm Bradley with Marvel Machining.
On today's episode, we're going to talk about a variety of tooling topics, such as when to pick a thread mill over a tap, Indexable versus solid carbide tooling, and our favorite kinds of work holding. Let's get started. Guys, how you doing?
Good. How was Christmas?
That's good. Nice having a bunch of time off.
How much time did you have off?
Oh, well, let's see. We were off from the 22nd until we're not going back until the 2nd of January.
Nice.
So that's the most time off from work I think I've ever had.
Really?
Yeah. I know we kind of talked about this on a previous episode that I was actually on. This is our first episode of the new year. So anything big coming up for you guys in the new year that you know of?
No, I don't plan too far out in advance, so
Right.
Yeah. Nothing really new for us. I've already talked about like the ERP stuff and inspection stuff, so that's
Okay.
hard to cover. But yeah, nothing really new, just back at it. When we get back, there's jobs waiting for us. So
I do got a production job that I'll probably starting next week. It showed up today, but 420 parts. That's probably the most parts I've ever ran at once, but it's going to run in the horizontal.
nice.
So I actually ran it last year, and I still have 3 of the tombstones set up. The tooling's still in the machine, so it's ready to go.
Yeah.
Sweet.
So it's going to run around the clock. I think I got 4 tombstones set up for it. And the timing for it works out perfectly that about 8, 9, 10 o'clock, I can swap parts on 2 of the tombstones and it'll run overnight. And I can swap parts again by 8 o'clock and then it just runs all day again.
Oh, wow.
That's that home shop combo.
Yeah.
Yeah, buddy.
I might have to set up the tool break detection maybe. I might have to try it. I didn't run it last time.
Yeah.
There you go.
Is that the same job? What was it? I remember you had one where an end mill broke or something.
Yeah. I broke one, but luckily I caught it though. An end mill broke and then like 6 tools after that broke.
Yeah.
I caught it before it got too far.
Yeah. 6 tools isn't too far.
Well, part swap thing is too far. You
Yeah.
can't do a swap and start running another.
Yeah. Was that the same job?
Yeah, it was actually. Yep.
Yeah, maybe you should set up tool break detection. Granted, I'm sure you probably
Why not?
dialed things back a little bit after breaking a tool.
Yeah. And that was the issue. I think I went off of, I don't know what I went off of, but it seemed ridiculous at the start, but I left it.
Yeah.
And
Well, those speeds
Top-
where you look at it and you're like, "There's
Yeah.
no way that's gonna work. Like, that is way too much." And you're like, "Well,
Yeah.
I'll try it anyway, see what happens."
yep. I think it was a small drill. I don't remember. It was like 8,000 RPM and it was feeding at like 300 inches per minute. It was like a 60 thou drill or something bullshit. And I watched it go and I was like, damn, that was fast. But I'm going to leave it because they said I can.
Yep.
Wow.
But then I dialed it back and then I made it through 200 parts, no problem.
What so did a tap break or something behind it, and that's what
Yep.
you're in?
So a drill broke and then a tap broke. And then I think it was in a pocket that had something else going. So then an end mill came through and it clipped the tap and broke the end mill. I don't know. It was just kind of one of the things that continued going downhill.
Reaction.
Yeah. That's a train wreck. So on that note, that's a great segue. So we're talking about tooling in this episode. And one of the questions that we got like 2 months ago from an Instagram questionnaire was from the worst technician. And he was asking us for our opinion on when we should use a thread mill versus when we should use a tap. And, kind of getting right into it, to me, that's actually a great reason to use a thread mill. A thread mill can't really get stuck in a part. I know for myself, we don't really do a lot of thread milling unless it's either we're shooting for a certain class of fit. Like if we do parts with like a 3B class, I usually thread mill them. I know you can get taps for that. But I usually will opt for a thread mill because you can control size better as long as you have the right gauge. That is one of the downsides to thread mills, though, is you actually have to have the gauge, which a shop should have at least common size, gauges of thread. I don't, most shops would probably consider 3/8 thread to be pretty common. So in that case, yeah, you should just have a gauge and go with it.
Do you guys not thread 3/8/16 very often?
It depends. When the right job comes along, sometimes we'll have to do that.
What could be a good workaround if you don't have a thread gauge? How could you go about making your own? This is possible. You can make your own.
Right.
You make
So,
your own
I mean, yeah,
external thread. You can use 3 pins.
Mhm.
right.
So you can
It,
use thread mics or the pin method or triangles. Yeah, you can measure your pitch diameter, make sure everything's correct, and then thread mill and use that as your gauge and you can make a min and a max, and then use that as your thread gauge for a female hole.
right.
Yep.
And that's really the best way to do it. If you don't have a gauge on hand, which, thread plug gauges and ring gauges too are getting easier to get.
Mhm.
You can get them in sets pretty cheap nowadays. But like if you just don't have time, you're setting up the job now. That's probably the best thing to do. Put the go, do it
Better.
in a lathe, a manual lathe, or even actually a while back we thread milled uh it was like a M280 by 2 thread gauge. Um, I will admit we didn't make really a go and a no go, but like we had a physical part that we could check and match.
Yeah.
And we knew, okay, as long as these two, because there's
Well,
like two parts, as long as they match the fit, we're good.
we've made thread gauges before too, like plug gauges, and we only made the go, um, and
Hmm.
turn it on the lathe, and then like measure it with the thread triangles, and then kept it at the say what would we have done? I guess at the max diameter for the go, or no, the min diameter for the go. So then we were thread milling a female hole on a part. Use that, and we kept checking it with that, and kept walking the thread mill out until it would go. Um,
Yeah.
Yep.
but like like say it doesn't go, and you offset your thread mill out a thousandth, and then it goes. Like there's no way your no go is going to go right.
Right.
And you kind of with experience and feel, you can tell too when you put a thread gauge in, like how much slop you have. I've
Hmm.
noticed that myself. Like I could drop that in there, and you can feel just by shaking it, like it's pretty loose. The no go might go on that one, or you can feel where it's like maybe a thousandth or two of slop. Like
Yeah,
we're tight for
we're
sure.
good.
So that is a unofficial way to work around not having a thread gauge.
Yeah.
Oh, and there's plenty of shops that will use a bolt or nut.
Mhm.
Yes, and I'm guilty of it too. I've done it, but
Yeah.
I mean, a lot of times I know the fit function. I know what it's going to go to. I know that they're not too concerned about it,
Right.
which I mean isn't right or wrong, I guess. But
Look,
I typically if I use a bolt, I'll do kind of the same thing you just said when you're making your threading gauge. I'll make it so it's a tighter fit.
yeah,
It's not loose.
yeah, yeah.
Yeah.
Sometimes that's all you need to do. Like, say somebody needs some parts made for like some heavy equipment or something.
Yep.
Just some random stuff like that. It's like it doesn't need to be dead on to be like gauge perfectly. Honestly, a lot of that stuff is going to be 1B anyways. So
Yep.
yeah, if you're using a bolt and fitting it to the bolt, chances are it's going to be just fine.
Yep. Fit function.
Yep.
Right.
Yep. Then obviously, like if you're making a part going on an aircraft, you better have a gauge and you better make sure it's right.
Correct.
Especially if you know your customer is going to inspect it too.
Right.
Make sure you're inspecting it too before you
Yeah.
send it off and it gets inspected.
A lot of times what we'll do, I mean, at least with male threads, inside threads are harder to check because, I mean, male threads, you can just put a pitch mic on it or, thread wires or whatever. But a lot of times, we'll check the major, we'll check the pitch diameter with pitch mics or wires. And if we have a nut, we'll just check it to make sure that like the thread pitch is correct.
Right.
Because obviously if a nut goes, it'll probably be loose because most of your generic Ace Hardware type nuts and bolts are going to be kind of a loose fit.
Yeah.
But so
That's
that works.
There's another thing too on as far as your thread pitch goes. Like if say you're doing it on a sloppy lathe, like a sloppy CNC lathe, and you can't always trust it. I haven't experienced it, but I've heard of people having that problem where like their pitch will be off just a little bit. Like
Mhm.
if you have a lathe that you can trust, then chances are if you program it to be, like 16 pitch or something, then it's going to be there.
I actually had a another small tangent. I actually had a problem here like a few weeks ago of one of our SL20s, which it's had this issue before. I was threading something. It really wasn't a thread, but it was like I believe it was just 20 threads per inch. And it really was just to rough up the surface, but that's what they called out. It was like, I think 30 thousandths deep per side and then 50 thousandths pitch. Um, so we'd set the parts up on our newer SL20 and they did great. We want to go ahead and set them up on the older SL20 we have just to try to run through the job quicker because it was like 1,200 something parts. And I could not get the pitch to repeat the same with the same program, same tool, everything. And we finally figured out that the encoder belt on that machine was slipping or the pulley was slipping. So it just would not from pass to pass. It wasn't the same lead. I ended up with just a mess by the time, it ran through a couple of passes. So, and even on here's a trick for you old school guys that crank handles every now and then, all 5 of you. And I learned this from A-Bomb 79. It's best if you're setting up on a manual lathe and you gotta switch gears and all that stuff to, single point of thread, put some Dicam or a Sharpie on your major diameter or your minor if it's an ID thread, and just take a scratch pass and make sure your pitch is right. It's so easy to get, one lever off, especially on a lot of newer lathes that are like imported and they're written in English, and you can't tell, if you're on A or B or Q. So that way, okay, yes, I'm cutting a, 16 TPI or, you know, 2 millimeter
That's
pitch or
how
whatever.
I did the same thing.
that's how I was taught 20 years ago. We would Dicam it and then, take a small pass and measure it and adjust from there.
I learned the same thing on YouTube.
Put that on your resume.
Yeah.
I like Cam. I think you shared this on the last episode with Sean. How you got all your thread mills set up now, ready to go, each size. I think that's something I'm going to work towards this year. I'll thread mill. Typically, if it's over half an inch, I'll always thread mill. But anything smaller than that, it's just always quicker for me to grab a tap and do it, unless it's an odd size I don't have.
My theory on when you should thread mill versus when you should tap is there's a couple different things to consider. One is the cost of your part, but not the cost of the customer, but the cost that you have invested in it. So, how
Yeah.
expensive is the material? How much time have you invested in this part? By the time you get around to tapping, if that tap breaks in the part and you can't get it out, how expensive is it or time consuming is it going to be for you to go back and make that part again? And then another thing would be quantity. If you have
Mhm.
a large quantity and it's somewhat automated to where, like what you're about to do, Brad, where you're going to have 420 parts and it's running unattended. You come back and your tap broke. You might have 6 broken tools behind it. And then now you have a bunch of half machine parts that only have like one tool ran because,
That's a good point, because I am planning on tapping it, but I did opt for thread form tapping.
yeah. And form taps are pretty
I don't
good.
know.
They last a long time.
Yeah.
And it's aluminum, right?
Yep.
Yeah. So I wouldn't think you would have a problem with that.
No.
But if your drill breaks, whatever. Now, if you're doing tool break detection, that'll help you there. And then you'll run into the same problem anyway. If the drill breaking was the issue, like if you try to thread mill that behind a broken drill,
Yeah.
it's going to break your thread mill. Now,
Yeah.
your end mill isn't going to run into a chunk of broken tap in the part, so there'll be that. You'll just have a whole bunch of parts that aren't tapped.
So when you run tap break or tool break detection, do you run it on the drills and the taps?
I would run on anything you're concerned about breaking. Like,
Yeah.
say you're running aluminum
Mhm.
and like you're not really concerned about an aluminum end mill breaking.
No.
Like that's chances are it's going to last the whole job. So I wouldn't bother checking the end mill, but I would definitely check the drill and check the tap because taps can break. Sometimes something weird just happens. I've had taps break. I'm like, I have absolutely no clue why that thing broke. It's tapped all these
Oh,
both.
yeah.
So checking a drill, checking a tap, anything that's questionable, or if it does fail, it's going to be a catastrophic failure because of what's going to follow behind it. I would
Yeah.
I would run break detection on. It would break detection if the machine knows how long your tool is. It should be able to wrap it right to whatever set dimension above your tool setter and then check it real quick. So it shouldn't be a long process, but
Mhm.
yeah. Um, but no, with thread milling versus tapping, um, yeah, what material are you using? You know, like say you're tapping a really hard material and there's a higher chance of it breaking. Like
Yeah.
we had some parts that we used to make. Well, we still make them, and it's a plate that has a whole bunch of 5/16 18 holes in it. And we used to pretty much just accept the fact that we were going to break some taps. We would make extras, and we were form tapping them. So we were drilling a little bit oversized from what's recommended for the form tap. And then I think part of the problem too was we had the tap depth was so close to the bottom of the drill depth. So using a form tap, you can get a lot closer to the bottom of that hole because you don't have to have those lead-in threads like with a cut tap. And so we were form tapping, and it was pretty much guaranteed you're going to break a tap or two in that process. So we switched to thread milling. Don't break any more taps. We get good parts every time. We don't have to
Mhm.
make extra sacrificial parts just to be safe. You know, we can just do it. But so
When do you when do you use single flute versus multi-flute?
I hardly ever use single flute or single point thread mills. I keep them on hand in case you have like a weird thread. Like
Yeah.
just the other day, we had it was like a 25 millimeter by 3 millimeter, I think. Something around that. I know it was a 3 millimeter pitch, and we don't have that. I don't think we had a tap for that. We did buy a thread gauge, just to have it in the future, but I think we found one for fairly cheap online. But
I think the other thing go ahead.
it was like the part's 2 inches thick and it needed to be tapped through. And
Yep.
we're like, we'll just use a single point thread gauge
Yeah.
or thread mill that we already have on hand. Thread mill, it was 2 parts, right? No point in getting a multi-point. Now, the nice thing about like metric, for example, is you have a lot of like once you start getting bigger, you have a lot of like 1.5 pitch or 3 millimeter pitch uh, threads. So if you do get a multi-point or a multi-form thread mill, it's going to work for a lot of different threads.
Yeah. Can you get the multi-flute or the what's the length to cut? Can you get pretty
I don't know. I mean, I know there's a lot of different options out there. Like I've got one that's made for 3/4 10 threads, and I believe it's got an inch and a half length of cut, but it's also necked, so I can reach 2.25 inches deep if I remember right.
Yep.
And so,
Mhm.
um, you know, I can really get down in somewhere. And now the downside to it is like, which is not really a downside. It's still way faster than using a single form thread mill. But you know, if I get to the bottom of that hole and start thread milling to the top, like that first pass, it's cutting with all the flutes. And the
Yeah.
last, 6, 7, 8 passes, whatever it is, um, you're just cutting with that one top tooth.
Yeah.
So it feels, and you could probably, I'm not going to bother messing around with it just because I don't care and it's not worth the time for me. But you could probably do like full form, cut, 15, 20 threads at one time, whatever it works out to, probably 15 threads at one time, and then just cut those 15 and then lead out, come up and come back in and cut your last remaining 6 or 7, 8, whatever it is you have all at one time. But
Yeah.
I wouldn't want to risk things not meshing properly. I'd rather just ramp the whole thing all at one time. But
Yeah.
now we do drill and tap a lot. Like there's a lot of times where we still just use like load up a drill, load up a spiral point, spiral flute tap, and just drill and tap it. And we're primarily running steel and cast iron.
Yeah.
And usually if we have a tap break, it was user error. Somebody screwed something up, whether it was me programming it, I got my depths wrong or something, or somebody loads the wrong size drill, whatever, or I put the wrong size drill in the setup sheet or something like that. So there's always something that we did to cause it to break. It's never the tap is breaking because it can't handle the steel. I mean, it's like it's mild steel, so it's not like it's that hard. Um,
Mhm.
and so most of the time we'll just throw a drill in there, throw a tap in there, and drill and tap it.
Yep.
Yeah, that's what we do too. I mean, we thread mill basically in like certain circumstances. If it's
Right.
I'm gonna say probably most of our thread milling really is oddball stuff. So if it's a big thread that just isn't gonna work too well on our lathes or just, just something odd, we'll break out a single point thread mill. We generally just do full form thread milling for like specific jobs. Like I said, that one that we had a bunch of, I think there was like 500 parts and they each part had three tapped holes on it, and they were all a class 3 fit.
Yeah.
So, so I would say where you would actually opt for tapping versus thread milling is if you need speed,
Right.
because I'm pretty sure any kind of tapping you're gonna do is gonna beat a thread mill for speed. Um, unless maybe it's a really big tap, like a 3/4, 1-inch tap. And if you had a full form thread mill, you might could match speed pretty well in that. Um, but
And
we ran like 20,000 prosthetics parts here last year, and they had 632s, 832s, 1030, maybe 1032s as well. We tapped all of them,
yeah.
and they did great. If we'd have thread milled them, I mean, that would probably add 20, 30 seconds to the cycle time, and that does matter on jobs of that volume.
Yeah. And with a hole that small, you're not thread milling fast.
No,
At least
not
not
at
all.
all.
I mean, the diameter of your tool
Mhm.
in relation to the diameter of that hole is probably gonna end up being kinda close in order to get the rigidity that you need to thread mill as deep as you would need to go. That'd be my guess
Exactly.
anyway. But, no, another time where we pretty much always thread mill is with NPTs. And
Yes.
if you've got a good NPT thread mill, like full form NPT thread mill, carbide thread mill, you can thread mill pretty fast.
Yeah.
Like, we've got some, there's some half-inch NPTs I was thread milling the other day. I think it was half-inch. Um, and I mean, I was thread milling them at like 40 something inches a minute, which with a hole that small, like the circle that you're doing is not very big. And the way I'll do it is instead of like thread milling it once at like final dimension, for example, and then coming out and dropping back in, thread milling it again as a spring pass, I'll just do two full helixes. So what's a half?
Mm.
Is a half 18,
I
half inch 18 MPT?
think a half is
I
14.
usually remember it until, yeah, it's 14. I usually remember until I'm on the spot. Um, So, yeah, have 14 MPT. So what I'll do is, like, I'll do the math, 1 divided by 14 times 2 plus 1,000. So from my bottom depth to my top, or from my bottom height to my top height, I'll make the difference that formula. So, whatever 1 divided by 14 is. So I would do, let's see, 1 divided by 14 is 71 thousandths. So I would
Mhm.
times that by 2, that's 142 thousandths. Then I would add a thousandth to that just to have a little bit of overlap.
Yeah.
So, say my bottom depth is, 3/4 of an inch below the top of the hole. My top height would be offset from the bottom depth, 143 thousandths. So now what it's gonna
Yeah.
do is drop in and then do 2 full helixes and that, like, little bit of overlap, and then that's it. The hole's done, because now you've got your spring pass built right into it all at one time.
That's smart. I'll have to remember that.
Yeah,
For sure, NPT is one spot where thread milling is really the way to go. I've
yeah.
only ever done it on small stuff like 1/8 inch. We have one job that we make a lot of these, they're basically bushings with a 1/8 pipe tap on the side,
Mhm.
and I used to tap it because I didn't realize we actually had an 1/8 inch, NPT thread mill in the shop. Um, and, like, it's faster to thread mill.
Yeah.
Because with pipe taps, I mean, you get a lot of tool pressure and you get a lot of threads tearing, and they just look
Tearing
like
is
junk.
Yeah. The tearing is
Uh,
what always steers me away from it.
right.
I've never actually tapped an NPT, like, on a CNC machine, like,
Mhm.
as part of the program. No.
It helps a lot if you I've never actually reamed
Yeah.
the taper, but I've ball milled the taper of an MPT in there before I tapped it, and it helps a lot.
Yeah, that's I've heard that same thing before too, but then I'm also like, well, if we're already at that point, I might as well skip that process and just thread mill it.
Yep.
But of course, now we have thread mills to do that. If we didn't have
Yeah.
all the thread mills but had a tap, then I would consider it, especially if there was a quantity. A lot of times what we've done just to prevent the possibility of breaking a, NPT tap or something is we'll just drill the hole, like, run the whole program, drill the hole, chamfer the hole, and then at the end of it, we'll come back with a sprung center and, like, a drill chuck or something, and then just go to that
Yeah.
rotation and get it started by hand and then do it that way. But
Mhm.
I don't like doing that. It's just time consuming and
Yeah.
a lot of time taken up for the operator when they could be doing something else. So
Yeah.
now, which is why we invested in getting thread mills set up, and so we just thread mill all NPTs now. I need to get a NPT, solid carbide thread mill. That's the last one I need to get, but I've got 27
Mm.
through 11. So
Nice.
Nice.
way better
Nice.
too going with a multi-flute, full profile, solid carbide over like a single insert thread mill. Those things take forever. And I mean, that's what we've done
Yeah.
for a long time. They work, they get the job done, but man, it's slow, especially when you're trying to walk that out to gauge. Like, yep,
Mm-hmm.
so slow.
For sure.
But yeah, I guess I would say I would choose to tap over a thread mill if the risk of that tap breaking is not very high, and I don't want to put the effort into programming a thread mill and dialing in a thread.
Yep.
And then
I agree.
if the risk of breaking is high, as that risk being like the cost of material, your time involves, um, whatever, then go with the thread mill. Or if you need process reliability, that's another one. Once you get your fees and speeds dialed, chances are you're going to be good with the thread mill, and you get your offsets dialed. But you also have to worry about operators keeping up with the wear offsets for the thread mill and making sure they gauge and everything too. So that's another consideration.
Yeah.
Need to get them gauges.
And you got to get
Yeah.
the gauges.
Very important.
Yeah. What
Yeah.
you guys know what the deal is with like carbide thread mills? Yeah, some of them will say like for internal threads only. I've noticed a lot of
Did we
that.
talk about that?
I feel like we did. Like
I have.
I
Yeah.
I don't remember what the consensus was.
I don't know. I've ordered them where it says internal thread mill. I've used them on external, no problem.
Yeah.
I thought I read somewhere there's something with clearance, but it still doesn't make sense to me.
Yeah.
I feel like we had to do an Acme thread one time, and I got it was an internal Acme thread, and I got a thread mill for it, which it was actually a single point thread mill. But it was sized for, I think it was a 5 TPI Acme, and I don't remember if it said it was for external or what it was. But the first one we bought, we had actually had a gauge for it. I think the customer sent us a go no go for that Acme thread, and it was the oddest thing. The no go gauge started going before the go gauge would start. Um, and that really perplexed us all. Uh, what we figured out is there was something about the relief on that was ground onto this thread mill that was making it drag and make the width of the slot too wide before your actual pitch diameter was big enough. So I hope I'm not getting this backwards. I believe the no go does not gauge your major diameter on bigger thread gauges like that. So it was checking that that was good, but then the go gauge wouldn't even start because the pitch diameter wasn't near big enough.
Yeah.
So I ended up buying it from that same tool. I ended up buying it from a different source, and it worked fine. And I remember, I think I tested, like I just took a small cut on a block and put it on the optical comparator, and I could see there was like a 5 or 6 thousand difference in the tip flat width
Hmm.
on those two tools.
Interesting.
So I don't know if it had to do with the external internal thing
Yeah.
or not.
I just Googled it,
Hmm.
and it says you cannot use internal thread mills for external threads when threading metrical and unified threads. They have different profile for internal and external. The internal thread has a bigger crest than root, and for the external thread, it is the opposite. The root is bigger than the crest.
The what?
I don't know. I've done it. It works just fine.
A bigger crest than the what?
Uh, the internal thread has a bigger crest than root, and for the external thread, it is the opposite. The root is bigger than the crest. What's a root? Something you find under a tree.
Oh, I've never heard of that.
You Minnesotans
Oh
make
my.
me sick. All right, let's move on.
Hmm.
So
Well, the crest. So the crest is the flat on the external on the top, and then the root is the bottom little.
hmm,
Yeah, I guess okay, I can kind of picture that
yeah,
Yeah.
because your minor diameter of your hole is what creates the crest of your thread
Yep.
in relation to the actual thread. On an external thread, I guess you need, well, no, I guess you could do the same thing with your major diameter on the external thread. You would just use
Yeah.
the major to create the crest. Or
Mhm.
would that be the crown? That'd be the crown, wouldn't it?
People are gonna
Yeah, we're gonna get blasted for it.
Oh, yeah.
This is what I had the machinery's handbook for. Every time I need to figure this out, I do get back to that.
Yeah,
Yep.
for sure.
I don't know. I have a single point. I've used them for internal and external, and red gauges work both ways.
Yeah.
Right.
I'm sure if you, like, really got into the science of it and the nitty-gritty of it and, like, super in-depth inspection of it, then there might be a slight difference, but the shit threads on, so
So, I mean, if you're doing work
Red gauge says it goes and no goes, it's good.
right, right. Yeah, I
yeah.
mean, if you're doing work for, NASA or something like that, you might wanna do a little bit more research than listen to these 3 knuckleheads.
Yeah. Whereas if going on a dump truck, you're probably fine.
Yeah.
Um, the one thing I wanted to say about thread milling is I know a lot of people, or maybe not a lot of people, but people will set up templates for different threads. So they'll have thread mills set up for all their different common pitches that they do. And then they'll have hole recognition or maybe feature recognition, whatever it is on your different CAM software, and have templates set up to drill and thread mill those holes. So it's not like some big drawn out process every time you need to thread mill a hole. And so there's
Mhm.
some people, they don't tap at all unless like something specifically calls for a form tap or something like that. They don't tap at all. They drill and thread mill. Some people don't even drill. They'll just use an end mill to interpolate the holes.
Yep.
So
Nice.
That's how my system's set up. It recognizes the hole in the tap, and it automatically it pulls out an operation for a cut tap. But I can open it and I can change it to a form tap or red mill, and then it changes its process based on how I can set up.
so
And I think I can default to thread mill it too.
yeah. So on the topic of taps, cut tap or form tap.
I cut tap.
Yeah.
Yeah, depends on the material for me. We stock cut taps. I mean, we stock both spiral point and spiral flute. Um, I don't generally bust out form taps until it's a high volume job and it's in like aluminum or stainless or I do know that, they do make form taps now that are good for tool steel,
Hmm.
which is mind blowing. But
Like hardened.
uh, honestly nowadays they probably do. I just mean like standard annealed tool steel.
Hmm.
When I was getting into the trade a decade ago, um, the knowledge that I had at that time was like form taps are for soft ductile materials. So aluminum, copper, stainless, even stainless was dicey. But now it seems like over the years, like, OSG and Balix and Nachi and all these other brands have come out with these form taps that can be used on tool steel. That can be used even like 4140 pre-hard. So, I'd say we'll see the day that you can form tap. I know you can thread mill hardened steel.
Hmm.
So,
I've seen those thread mills too. You can use in hardened steel, by the way, that are in cutting.
right.
So instead of drilling a hole, or like you don't need a hole first at all, you just go straight for it. And I think they're
Mhm.
left hand cutting, and you what would normally be climb cutting, but it's actually conventional cutting. I think. Hang on, this is hurt my brain. Spin backwards from normal, but you go from the top down. That way, you can cut from the top down without a hole. And since they're end
Mhm.
cutting, I figured that the end of it's probably something similar to like a high feed mill geometry. Anyway, yeah, you just whatever the pitch of your thread is, that's the rate that you interpolate down at. And
Yeah.
it's one shot. So you just interpolate down, then lead back to center, and then pull out, and you're done. And you can do it in hardened stuff. I think the example that I saw was in hardened A2, like somewhere in the 50s. Yeah, rough. We'll see.
I think John Saunders has a video. He's showing off some brand of thread mill like that, and I think it was like 60 Rockwell D2.
Hmm.
And I mean, that's just mind blowing, man.
Yeah.
Imagine showing that to somebody that, got out of the trade 20 years ago, you
Right.
know. I
You
mean,
don't even need a
that's
full can. You just
right.
go straight for it.
It's crazy.
Feeds and speed.
Yep.
Right.
Um,
Right.
yeah. Now we typically, and we primarily run steel and cast iron, and we usually use a cut tap. Part of
Mhm.
that because a lot of our prints call out. They don't just say like this size thread, this tolerance. They'll say like use this size drill. And so when you're done, you want to make sure your miter diameter is whatever size drill they call out.
Oh,
And I've noticed too, like with different materials, like using a form tap, for example, with different materials, you'd have to use a different size drill in order to get a different miter diameter when you're done. So
Yep.
like say you're doing metric and you got 6H tolerances to hold. That's something that's actually bit us before is we were using the proper or the recommended drill size for a form tap and drilling it, form tapping it, whatever. But then our hole was too small. It was below the minimum tolerance of the 6H miter diameter.
hmm.
You got to play around with drill size, and it's not like if your hole say your miter diameter is 6 thousandths small. It's not like you can use a drill that's 6 thousandths bigger because then it's going to be like 15 thousandths bigger because there's so much less material to get.
Could you go back in and follow it with a drill
Y-
or a reamer?
yeah, you probably could, um, but then you got to have a reamer of whatever specific size it is, and
Yeah.
I'd rather just cut tap it and yeah,
Sure.
which is what we
Right.
started doing. And it's something else we noticed because we'll still use. I know a lot of people don't like it, but like drill chucks and like tap holders, like tap adapters, um, we'll use those all the time. But if we're gonna do like,
You can put them in the category with them welding holders that Pat uses.
yeah, yeah, no, a lot of times like we use a drill chuck for example. People always talk shit about them, but they work perfectly fine if you're not doing like super tight tolerance or like
Yeah.
true position holes and stuff like that. Like if it's 5 holes on a 5-inch bolt circle, 5/16, 18 or whatever, throw it in a drill chuck, drill 'em, you're fine.
Yeah.
I don't even, um, like, I know there's a lot of controversy around how and when to, spot drill, but, like, in that scenario, on, like, a freshly machined surface where I'm gonna go back in and drill, I wouldn't even spot drill. I just go straight for it with it. We use 135-degree high-speed steel drills for a lot of that stuff,
Hmm.
and a drill chuck, and it works just fine every time.
Yeah. I mean, I think you know the tolerances of your parts. You know what you can get away with.
Right. Yeah, and this is
Yep.
like the whole location is plus or minus 20,
Yeah.
and even still, we don't even have that much variation. It might be a thousandth variation whenever I'm checking whole locations. It's not anything crazy, but, um, now if it needs to be something super, super accurate, then I'll either use a, ER holder, like a collet holder, or, which still isn't super, super accurate, but either a collet holder or just interpolate it or drill it, then come back with a mill and interpolate it.
I just use standard collets for my taps.
Yeah.
Kenny's hassled me for that, not using tap collets.
I we use
Mhm.
tap pallets. We've had them now with like a half 13, had it slip in a regular in steel. So
Yeah.
like if you were to use like a half 13 spiral point semi bottoming tap or bottoming tap in a normal collet, like I would be super nervous doing that because you've got like
Oh, I do it all the time.
well in steel or something like you've got 2 to 3 lead in threads in steel with a semi bottom or with a bottoming tap. Or is it semi? I think 2 to 3 is still bottoming. Anyways,
Yeah.
not a lot of lead in, so that's a lot of force on it. And yeah, having that like the square end on the back end of a like basically something to drive, like
Mhm.
something built into your collet to drive the tap,
Yep.
mechanical interference is pretty nice to have.
Yeah.
Nice insurance, but no, with spiral flute bottoming tabs, we've noticed in those tap adapters, which typically work fine if you're form tapping or using spiral point tap. Um, it lets it walk a little bit too much, so then we'll have a
Mm.
bigger minor diameter at the first, like, 3 threads of the hole,
Hmm.
then it'll get the correct size. But we fix that by using collet holders with tap collets. So, which is probably
I'd be darned.
that's, like, best case scenario anyway, but a lot of times, it's so much faster to just throw it into a tap adapter, and it still works perfectly fine, like
Yeah.
spiral point, which we use a lot, or a form tapping, like, just go with that.
Well, now that we've dragged
Yep.
out talking about taps and thread mills for 40 minutes, and we'll move on to number two. Oh my goodness. Um, so Ohio Machinist says, ask for our thoughts on solid carbide versus indexable tooling.
I don't use indexable tooling, so
I was wondering about that. You've got indexable face mills, right, Brad?
yeah, and I've kinda moved away from using face mills. I do so this job that I got coming up, I'll use it on there, but I've been facing a lot with just an end mill,
Mhm.
and I kinda started doing that just to open up a pocket. I had some jobs that were coming up where I was, I needed 26 tools. So it was, well, I can swap out a face mill for an end mill,
Sure.
face it with an end mill, and that end mill can go do something else rather than, so I was kind of trying to organize my tools so I had enough pockets for the job and not have to swap stuff. And I just kind of I never put them back in. And I've
Mhm.
stayed away from it. I mean, I've faced 18 by 30-inch part with a half-inch end mill.
Yeah.
Oh, wow.
I mean, it's stupid. I mean, it's one part, so that extra 10
Yeah.
minutes, like, I'm not as concerned about it. But if I was to get into production, I would put in a 3-inch or a 2-inch face mill.
Yeah, that's
Sure.
kind of the question too, is like, do you have 20 more jobs stacked up behind this job that are all due soon and you need to hurry up? Or
Yeah.
can you just leave the end mill in there and just let it run while you're doing other things? Like your time
Yeah.
involved might be less just letting the CAM system figure it out and use the same tool and not load different tools, whatever. It's just
Yeah.
even just the brain power, like, I don't want to deal with it. I don't have to figure it
Yeah.
out. It's already sorted out. Just let it run.
Yeah.
I'll think
Well,
about it.
we always keep a 45-degree face mill. That's tool one in all of our mills. Um, so almost every part that we do, it gets hit with a face mill first. But I have noticed when you got later duty machines like I have here and like Brad has, um, you usually get a flatter part with an end mill. Uh,
Yep.
or you might have to take your face mill and actually run it twice to get a flat surface, especially on like the entry and exit of the part. If you got any tram issues, uh, yeah, they get exaggerated when you got any tram issues.
I've noticed something with face mills versus end mills. Like if you're finishing a surface, say on like a flat plate that's somewhat thin, seems like face mills like to pull the part around. Like they kind of like
Yeah,
pull up in the middle of the part. Whereas if you're using an end mill, it doesn't do that. So you can just go back and forth. And plus, if you want a truly flat surface, like the best way, like if you want a dead flat surface, the best way to do that, which is very time consuming, is to use a small end mill with a small step over. Like you're going to get
Mhm.
the best results with that, but it's
yeah,
just not practical as far as time goes. You could spend an hour just facing a part doing that.
yeah,
But no, that is something I've noticed, and I try to keep in mind when I'm programming. Like if I've got something that's spans across like say it's just a wide part, like a big plate or something. It's like 3/4 of an inch thick or whatever, some sort of thin part. And I'm not doing vacuum, then yeah, you can use an end mill and just step across it. I'll climb cut the whole way across. So I'll cut across, wrap it back over to the right side of the part again, cut across, and do that all the way across the part. And I'll leave I'm not going to do like 50 thousandths deep on my finish. I'll leave like 5 or 10 to finish with my end mill.
yeah,
I do that too. I usually leave 10 or 15 and then I take a finish pass.
Yeah.
yeah. Same. You know, my first thought when it comes to indexable versus solid is of course milling. It's like you've got indexable face mills, indexable end mills. They've even got like interchangeable head end mills.
On that interchangeable head, I did
Mhm.
for this job that I ran, I did get a interchangeable ball and mill I had to reach 8 inches, but I got a solid carbide bar with an interchangeable small mill, and that worked great. It was super nice.
Wow.
And I went that route because in my head, I thought if I ordered a solid carbide and it broke, I would have to spend another $400 on another end mill, or I can replace a tip for $30.
Right.
Yeah,
But
that's
that
a
bar,
good
I think it
point.
was $1,100 too at the
Yeah.
same time.
Oh,
But I have it now
Right.
for
That's already, justification is now you have it for good.
right.
Yeah.
So, when it comes to lathe stuff, not that I want to scare you, Brad, um, but when it comes to lathe stuff, obviously for your turning, threading, grooving, parting, you should be using indexable.
Right.
Uh, there's really no reason to use a solid tool, uh, nowadays, unless you need like a form tool, for a special feature that you want to get put in fast or something. But um, kind of a hybrid between milling and turning. We actually just started using a face mill in our live tool lathe, which I've never done before. We'd never had the right adapter for it, and I wasn't sure if a Haas live tooling, machine would really be able to drive a face mill. I had a guy bring me one that's kind of newer product that's come out, and he brought me the arbor for it, And so we've been, on these bolts that we've been running for months now. We have been going through, I'm going to say, two end mills a week, and that's getting like 150 to 200 parts off one end mill. Half-inch end mill. Cycle time's about 40 seconds per part for that end mill.
Do you know how much that
And
is?
yeah, I was getting to that. It's, I think, $55. So, it's not expensive, but when you think about it, okay, you're looking at 100 plus, maybe even 150 plus a week in, you know, tooling costs just for that end mill, depending on if you run 4 days a week or 5 or whatever. So the tool guy brought me this face mill, the Arbor. It's a 2-inch face mill. It's a square shoulder face mill. So we'll have about $1,000 invested in the shanks, the face mill, and the pack of inserts. But for one, every time I flip edges, which I have yet to do, it's going to cost me about $25. And in a live tool lathe, I mean, it takes about the same amount of time to flip 5 inserts as it does to swap out an end mill. Let's be honest. Um, but the cycle time has gone down from 40 seconds to like 16.
Yeah.
So when you start looking at like the added productivity, because we're running thousands of these blasted things,
It could take you
um,
5 minutes to turn your inserts and it wouldn't matter.
exactly. And then so far, I think before we left for this holiday break, I think we were up to like 130 parts on the first edge. So not only, we've increased the productivity and the cycle time has gone down, we're probably looking at least cutting our once we get past, the initial investment, just like with Brad's, long arbor for his replaceable heads. Um, Once you get past that, you're really saving a lot of money when it comes to swapping $25 worth of insert edges versus a $55-$60 end mill.
Yeah. Yeah.
So
When you can pay for your tool
mhm,
and then some.
exactly. So, and, I had a lot when I posted it on Instagram, I had a lot of people offer up their doubts as to how well it was going to work on a Haas lathe. I'm really tickled with it. I'm not going to say you could do that with like their older style of live tooling, because I know at some point they went from a belt drive to a gear drive. Um, but it's working great for me.
Nice. Yes. I would say that's a good example of when you could use indexable over solid. Uh,
Hmm.
whenever I think of s- when I would run um, indexable tooling over solid carbide, typically I'm thinking of milling because I don't really know any scenarios with turning where I would use a solid carbide tool. I think pretty much everything's indexable there. I mean, it's so much more cost effective for your general like grooving, parting, facing,
Absolutely.
whatever, boring.
And
Maybe
better drilling.
carbide drills. Yeah, I could see that. Solid
Yeah.
carbide drills. Um, but no, anyways, with milling, I think with indexable versus solid carbide, typically when I'm having that debate with myself, it's high feed milling versus cutting with an end mill.
Mm.
And the considerations I'll have are the quantity of the part and how much roughing there is to do, uh,
Mhm.
and cycle time and cost. So, if you have a lot of roughing to do on a part, with like in a material that's going to wear your carpet down. So not aluminum, but like steels, stainlesses, or tool steels, whatever. It's going to be more cost effective typically to use a high feed mill with indexable inserts. However, that doesn't mean it's going to be faster. So
Mhm.
you kind of bounce back and forth between is it worth the cycle time? You're like, am I going to say I can run one part in 30 minutes with an end mill, but I have to replace the end mill every 2 parts versus uh, one part takes an hour and a half with a high feed mill or an hour with a high feed mill, but I can get 3 parts out of one side of my inserts. Um, you know, it's really just a big math problem. Go through, add up
Mhm.
how much the cost is and all that stuff on each of those things. Um, I prefer to go with high feed milling um, whenever I can if there's going to be a lot of roughing. Usually, like I was saying, it's more cost effective, but again, it doesn't mean it's faster. A lot of people get confused, or they just are maybe just inexperienced with high feed milling. High feed does not mean that it's going to be the fastest thing out there. A lot of times,
Yeah.
high feed milling is slower than a carbide end mill, because if you're running the carbide end mill the way that you should, I don't always go straight for the carbide end mill there. But so anyways, with high feed milling, it could be $30 for your inserts, and you could get 4 cutting edges per insert. So that's pretty cheap. Typically, I can't beat that with a carbide end mill. And a lot of times, when I'm choosing a high feed mill, you can stick that thing way far out in comparison
Mhm.
to a mill and not have chat, or even a face mill and not have chatter issues or that sort of thing. And if you're reaching that far out with an end mill, that's going to be an expensive end mill. Like a 3/4
Mhm.
one, something we keep on hand is like a 3/4 by 4 inch, like the cut carbide end mill. And those things are $350 a piece or something.
Ooh.
Yeah.
Yep.
So that ain't cheap. And you
No.
work through that in a few parts, depending on what you're doing. Like, that really drives your cost up. To me, in that scenario, it's worth it almost every time to just run the high feed mill, even if it's
Mhm.
gonna take longer, because then I don't have to, 1, I don't have to deal with fighting chatter with an end mill that long. Um, I don't have to deal with possibly breaking that end mill going into a corner, because you're gonna wanna go the max length of cut that you can. Uh,
Right.
and then something like that, if you work into a sharp corner with that length of cut, it's gonna snap that tool pretty easy.
Mhm. It
Um
gets ugly. One thing that, I like to do in a case like that, kinda like a combo that I'll do is, like, so we keep a 2-inch long, half-inch end mill in our machines for, like, deep-ish roughing.
Mhm.
I'll rough around a part with that. Let's say it's a part that's got, like, a 3-inch deep profile, and I don't wanna square it up, I wanna actually profile it out. I might come in and do, like, 1 3/4 deep around it with a 1/2 inch, and then I'll come in with a high feed mill and get the rest of it from there down. And then I usually have a neck 3/4 like what you're talking about that I'll come in and rest machine when I need to from the high feed mill and
Mhm.
then take my finished passes. So it's kind of the same concept. You're putting the bulk of the wear on your cheaper tool to replace. If you wear out the edges on a high feed mill, no big deal.
Right.
They're generally pretty cheap.
Yeah.
But then if you wear out that 3/4, even the ones we buy, they're, they're getting up towards $200.
Mhm.
So certainly not cheap.
No.
Um, the biggest caution I have for people that do indexable milling though is, you do run the risk, especially with a high feed mill, if something goes wrong quick
Oh, yeah.
and it doesn't take long to wipe out a body.
Nope. And yeah, or cause damage to your machine.
Yeah,
Uh,
even worse.
we've had that happen. It was a 2-inch high feed mill on a 6-inch long arbor, and the inserts blew out. And I think what really caused that to happen is, this is a big flame cut piece of A36. And we're using the same high feed mill to cut through all that flame cut surface, which is hardened, and
Yeah.
then also rough out the bulk of the inside of the material. And it was great, I think, on the first part. Then on the second part, inserts still looked good before we started. Um, and somewhere in the process of machining away that hardened A36, or the hardened flame cut surface, it nicked the inserts. And once it got into roughing in the middle of the part, they just gave out on us. And so once one blew, they all blew, and it sounded terrible. It sounded like hammered dog shit. And then, yeah, it skipped the belt on the machine. It was a belt tri spindle.
Mm,
It skipped the belt, and it was like a chevron style belt. Um, which so basically it had, like, really thick ribs, or, like, really deep ribs, and
yeah.
so when that thing skipping, like, it was hard to do, and I think it actually bent the, the I don't think it was on the spindle side. I think the spindle was good. I think it bent the, shaft on the motor, on the actual spindle drive motor.
Wow.
Yeah, it never sounded the same after. No, the machine still ran great. Like, it
Mhm.
still did its thing. We replaced the belt, made sure the tension was right and everything. It just sounded like shit running after that, but
Hmm.
still with everything you gave to it, I mean, it didn't care. But yeah, so things can go bad quick, fast, and hurry.
Yeah.
Another consideration too with indexable versus solid carbide is machine power. So like if you want
Mm.
a deep, or like, say like that 3/4 inch by 4 end mill scenario I was talking about. Like if you're going to run that thing to where it doesn't chatter, you really want to get a load on that tool.
Yeah.
Maybe cut 70 thousandths, 80 thousandths wide, 6, 7 thousandths per tooth. and like really be aggressive to get a good load on it and keep it from chattering. Well, that could be a pretty high spindle load for a lot of machines, especially smaller mills, um, or older mills. And so high feed milling may be the way to go for you because that doesn't take a lot of power to push a high feed mill at all.
Yeah, for sure.
But that's also, just I would say the best trick for high feed milling. The best, well, I guess it depends how you look at it. But anyways, a good benefit of it is the reach you can get out of it because
Mhm.
your forces are axial instead of radial. So you basically don't have a side force as much of a side force on a high feed mill. It's really pushing your force down into the part, your cutting forces down into the part and up into the tool. So it's not going to chatter as much. So if you're trying to figure out something for deep pockets, that's the way to go.
For sure. Well, on that topic, let me run this idea by you guys. And so, you know, we we don't do like tall parts, 2.5, 3 inch tall parts all that often where we're profiling them out. Um, but when we do, we'll get one of those $200 neck 3/4 end mills. Um, and I like to keep a couple on hand. Would it be better for me to look at like what Brad set up, a carbide shank that can, I don't really want to reach deeper than about 4 inches. I mean, that's excessive on mills like we have. Um, but do you think it'd be better for me to look at a carbide shank with about 4 inches reach and then replaceable 3/4 heads?
The problem with that is going to be finding a shank that's smaller than the cutting diameter of the tool. That's the trouble that I've found with that. And a long straight shank like that is, it's great, but at that 4 inches of reach, I mean, it's going to want to chatter.
Yeah.
So what you're doing right now may be the best scenario, or go to a bigger diameter and use a shoulder mill and or find some sort of indexable head that actually has a larger cutting diameter than your shank. But
Mm,
for some reason, that's difficult to find. What I've done is just relieved it on the manual lathe real quick, so it's just a few
sure.
pounds smaller. I'd probably go like uh 5 thousandths per side smaller just to account for any flexing maybe, so you don't get any rubbing.
Yeah.
You should definitely not have any rubbing if you go 500 per side.
Right.
That would be
I run, I got a couple 3/4 inch. I got 3 inches of flute, and I usually relieve them an inch.
Mhm.
I've got a couple I've relieved a little further, but I think like Cam said, once you get, your feeds and speeds figured out for the right cut, I
Mhm.
mean, you can get through a lot with it. I use them for everything that I'm profiling over 3 inches, and they work great.
Okay.
I've thought about Indexable for it too, but I just buy these. I think they're the YGs. They're, $230 or something, and I have them in stock local so I can get them, and
yeah.
they work great.
Mm,
Yeah. No, I really like the reduced neck end mills with the short length of cut. Those things
yeah.
are awesome. I think that's what you're
Sure.
talking about, right, Pat?
Yeah, yeah, I used to keep ones that were like 3 and 4 inches of actual full flute length,
Mhm.
but I found it really, I mean, for our machines, it works way better just to have about an inch length of cut, and that seems like it's standard, about an inch long, and then
At that
neck back
diameter,
to 3 1/4 or something.
they're a lot more rigid because, like, you don't have
Yes.
the flutes cut away across that entire length of the tool. I mean, it's solid carbide all the way down to that last, like maybe inch and a quarter.
Yep. Exactly.
Right. The flute grinds out.
Yeah, them big parts I ran, I had a 3/4, 3 inches of fluid. I had it hanging out 4 inches, and I cut a lot with that, and then I ended up swapping over to, I think it had a 6 inch reach, but it was an inch of flutes, and then it was neck back, and
Okay.
that was what I used to reach everything further down,
Hmm. Nice.
and it worked great. But I've had great luck with that. The 3/4 with 3 inches of flute, just to cutting a full 3 inches.
Yeah.
I haven't had much issues with it.
Hmm. Okay. I'll have to give that a try. We'll go ahead and get started on the one about work holding. Um, so up next we have, I'm not sure how to pronounce the name, Regnilov. One of the kind of pick our brain on our choice of vices, whether we use fixed jaw vices, centering vices, brands, quality, stuff like that. I will say, up front, we do have to be a little careful when it comes to the brand side of things. So we're gonna have to be a little bit vague about that. We're in our case, we're pretty like old old school shop, so we have a lot of curd vices. So all of our machines have curd vices. Some of them are probably, I mean, I dare say some of them might be older than Brad. It would not surprise me. Like, and they look like they served through World War II. Um, but
Kurt Weiss is there from my hometown,
right, right, yeah, they're made in Minnesota. Um,
Ridley.
so, but they work. They don't have, they're not flashy. They're not fancy, but they get the job done. They're simple. So like if you just want to get up and go on it, yeah, I mean, a curd is a decent place to start, but we do have 6 orange vices. Um, those are kind of a newer, I don't know, they probably come on the market within the last, what, 10, 12 years,
Yeah.
something like that. They're you can switch between double station, single station. Uh, you can change jaws out quick, stuff like that. And we do use them. Like we keep 4 on our DM2 that has a pallet changer all the time. It's great for that. Um, so, if you're looking at production or stuff like that, or you need that versatility, pretty handy for that. I gotta say, when you're used to Kurtz, they're a little fiddly to get used to, just because they take a lot of different Allen wrenches and screws and stuff like that. But once you get used to that, they work pretty well. Now, Brad, you basically only use orange, right?
All my machines have orange vices. My verticals have single stations that can be converted to double. Um, and then my horizontal, it's got all self-center in different sizes. I haven't had any issues with them. They work great for everything I need them for.
Mhm.
Um, I do have a Kurt Weiss, but it's in the box, so it's brand new.
Nice.
It's hard to go back once you get used to something. Yeah, I think like you said, Pat. At first, it's kind of going through the different Allen wrenches, but I don't use car smart side of the vise
Mhm.
very often. So I'm rarely ever flipping things around, and probably 90% of my parts I use that integrated Sarah jaw for everything. I'm always clamping on that 60 thou profiling all the way around the part, so that's really handy to have in there.
Yeah.
On my vertical, my first 2 vices on the left side don't have solid jaws in it, and then my second 2, I have jaws in there for following up. So my first 2 are usually that first stop that I'm clamping with the Sarah jaws, and then I flip to the next one. So and it works great. And if you saw my post for that big job I ran, it was nice to be able to pull off the master jaws, and I threw on my own material. I made my own master jaws just for that.
That's pretty.
Yeah.
And I was able to sink it down so it wasn't sticking up above the vise, and got I got my max Y in there. So that's nice. And everything's replaceable. So I've had issues where I mean, I think Pat, old boy, has called me out on it once that he would never do it, but I machined a master jaw for a part. I had to mill it down, so I cut it a replaceable part.
Right.
Yeah.
It was what it was. Sometimes you gotta sacrifice something, and
Yep.
I just threw on a new one.
Yeah. Well, you always keep extra stuff in stock, don't
Oh, yeah, I got extra stock of everything.
you? Yeah. Which is a good way to go.
It is. That's
If
smart. I mean,
area of a machine shop, look at anything where if this one thing fails, it's gonna stop production and then keep
Yep.
extra of that.
yeah,
Um,
that's true.
Nope.
we're pretty much all Kurt Weiss, like just standard 6-inch Kurt Weiss. We have some self-centering vices. I typically use them on the fourth axis. We got a big trunnion for our fourth axis, or just smack it right on the face of the fourth axis because we keep like a 96 millimeter plate on the face of the fourth, and then our trunnion table actually attaches to that plate, and then I'll have uh, the adapter plates on the trunnion itself too. So typically, that's the only time I use the self-centering. Um, but yeah, other than that, it's pretty much just straight 6-inch Kurt vices, and then if it's outside of what can fit in a 6-inch Kurt vise, it's usually a weird shape anyway, so it's going to go on the table or in a chuck. I've got a lot of chucks that are made to go on the table as well. So that's
Yeah.
a good holding strategy for us. But we also don't do a lot of high production. I mean, we're usually high mix, low volume. It's 1, 2, 3, 10-piece orders maybe. Um, and so the benefits you get from like a dual station vise or whatever is kind of lost on us. It would be nice to have I'd love to have it just for like the random small stuff that we do, or like the random and occasional jobs where the quality's high enough to justify that.
Right.
I think every topic we talked about today kinda your quantity, 1 or 2 parts are you doing production is a huge variable.
Really, yeah, it is.
Yeah. Kind of factor.
Obviously,
Yeah, that's a good point.
if you've got quantity, palletizing is awesome. Because I mean, there is some stuff where I do that.
Yes.
Like there's some things where we'll make a high quantity of, or I'll make dedicated fixtures, and um, which that's a whole nother topic in itself, is going into like when you should fixture. I know we've talked about it before, but I mean, you could
Yeah.
beat that up for 2 hours is when you should fixture versus not. But
Yeah.
the ability to turn your vise into a pallet base is pretty nice to have. Which, not that you can't do it on the curt. There's ways to do it on the curt as well.
Oh, yeah.
You can make dovetailed jaws that'll pull your fixture down, and have a feature in there to locate or whatever. Or I've even made little fixtures that um, it's for some copper parts we make. It's basically just a plate with holes in a profile. Like the part is a plate with holes in a profile, and so you have how do we do those? It's been a while since we made them. Yeah, your first operation, you drill all the holes, and then we'll bolt it to a fixture. We don't face it on either side either. It's just, at thickness. So we'll drill all the holes and do the slots that it gets, then bolt it onto a fixture, and then machine the outside profile. And so what we'll do is I'll have one vise set up to do all the holes and the slots, then another vise set up with the fixture for op two, and I'll run them both at the same time because we usually have decent quantity of those. But I made 2 of the same fixture. That way you can, while the machine's running, swap out your fixture. But the fixture just goes on hard jaws. So it's got a step cut on the front and back, but the back step has a 90-degree wall that sticks out. So whenever you put it in your op 2 vise, you just drop it on your hard jaws, push it over until it stops, tighten your vise, and you're good to go.
Yeah.
So all just kind of built on there, quick and easy, down and dirty. So
Right. That works perfectly fine. We've done similar, even without true hard jaws, just cut step jaws into some steel jaws, and have an aluminum fixture against the stop, and it works. Is it as good? Like if you had to hold like some thickness or flatness tolerances in something like that, it's probably not as good as using whatever Orange calls it, the Delta pallet or whatever they call it, or even a bolt down type of fixture. But if you've got looser tolerance parts, it works just fine. So there's plenty of ways. There's even some companies that make like what would you call it? Like a way to turn your single station vise, such as a Kurt or Chick or whatever, into a dual station vise.
Yeah.
So
Yeah, the adapters
or a multi.
there's ways around it.
Yeah.
Yeah.
Um,
Yeah, but
on
then
that,
you're limited there too by your part size.
yeah.
I've looked into
Oh,
that. Like we hardly make any parts small enough to fit in there, so it's really not
uh,
that beneficial.
so like anything that we've ever talked about ever on any episode,
Yeah,
it depends.
It does.
it really does. I mean,
Um,
there's so many variables and so many different ways to do it. And at the end of the day, if you're getting a good part out of it, it's not the wrong way. So
exactly, exactly. Have
The
you?
best though is the best though is the guys that see your 15-second video and telling you're doing it wrong.
yeah,
Yes.
Like, they don't see the rest of the part to understand why.
yeah,
"Oh, you're doing that wrong. Why would you do it that way?" "Oh,
Don't
yeah.
you know that?
One thing I really like is like, say you buy a work holding product or input any variable there or anything there. Like you spend the money on this thing, and they're like, why would you buy that whenever you could just, like cut a dovetail into, some steel jaws or whatever. And it's like, not every, like Brad, for example, maybe you don't want to spend that much money on some sort of specific work holding product, and you have the time to just make it, then great.
mhm,
Go ahead and make it. Save yourself the money. You have the free time to do it. Like you've got one machine running, you're making money while you're doing it. Great, do it. We don't.
I get hassled a lot
Yeah.
for some of the way my I run my tool pass.
Mhm.
Everyone's like, "Well, if you did it this way, you could shave off your cycle." Alright, I'm not worried about cycle time, man. It's one part. If it's 5 minutes or 10 minutes, I don't care.
Yeah.
I
Exactly.
mean, I'm not running when I program I'm gonna reprogram this 420 part order. Um, the first time I ran it was 200, and I wasn't too concerned about it. I had plenty of lead time, and it ran overnight anyway. But here, insertable tools. I got two here, two 45 cutters. I'm trying to decide which one to do.
Oh,
When I ran
nice.
it the first time, I surfaced the 45s.
Yeah.
But now I'm gonna swap it out just to save some time. There's times when cycle time matters and times when I don't care. I mean, I got a part that runs for 20 minutes. I probably quoted it at 2 hours. If it takes another 20 minutes, I don't care.
Right.
It's not like you're doing it manually. You're not standing there making it happen. You're just letting it.
And like you said, chances are that machine's running. I'm probably doing something else anyway. And if I sped that cycle time up, it's probably going to sit anyway.
Yeah. It also comes down to, because like you've got a good process. You trust your simulation. You trust your software.
Yeah.
So if you don't have everything pretty well dialed in and you don't have that trust in your software, then maybe you will be standing there watching the entire part run and doing, be there on cycle stop, ready to stop it in case something happens. But you don't do that. You just let the thing run. You let it change tools and go right to the next one. So
I don't even lock my program in the machine anymore. If that screen shut off, I won't even care.
yeah, that's what I'm saying. Like if you trust all that stuff and you can just load your program and kind of watch the first tool start, make sure everything looks like it's in the right spot and let it run, then great. Let it take another 15 minutes while you're doing other stuff.
Mhm.
Who cares? What's the point? And obviously, if you have a bunch of jobs stacked up behind it that you really need to get to, then maybe spend another couple minutes to save that 15 minutes, whatever it is. But otherwise, just let the thing run, focus on something else, get another machine set up and running.
For sure.
Yeah.
Sometimes too fast of a cycle time can be a problem too.
Yeah, that's what I hate about production with short cycle stuff. You almost have to stand there. I get so bored.
Yeah.
I had a job I ran over the summer. Cycle time was like 2 minutes. It should have taken me 3 hours to run it. It took me like 8 because I couldn't stand there. I was so bored. I was like, screw this.
Yep. I do the same thing. Like my computers, we have our programming room off the side of the machine shop. And so if say I'm trying to run something that's got a short cycle time, like, well, it's 2 minutes. I can go back in there and mess around a little bit with something I'm programming. And the machine stops. I don't hear it stop. And then it's been like 5 minutes or 10 minutes. I'm like, oh shit, that's right. I was running machine. So then I'm better off just standing there running the damn thing on. But nobody wants
There has been some times where it's like, I need to get this job done. And I'll take out the M30 and I'll put a pause in there. So I'll put like a 30-second pause. So I'm like, well, now I got to swap the part. Otherwise, this thing's going to start going again.
Yeah.
Huh.
So then I'll just stand there, swap part quick, close the doors. You're going to swap part quick, close the door.
Wow.
Rosha would love that.
I was going to say, don't put that on LinkedIn. Now, man, that's where having like, a longer cycle time can actually help you. And this isn't just for a one-man shop. This can apply to a shop with employees as well, because, you know, if you want that guy to stand there and run one machine, that's fine. Nail your cycle time down at least as low as you can without outpacing him. But
Yeah.
what if your cycle time's 2 minutes longer, but then that guy can run another machine? And the same thing applies with a one-man shop too. So
Yep.
there's a lot of different ways you can look at it, and increasing your cycle time doesn't always have to be just, being kind of loose with your programming and letting some duplicate tool changes happen and having speeds and feeds like they're from 1980, that kind of thing. Let it be more like, well, can I run a couple parts at once or
Yep.
something like that? That's where your fixturing comes in.
So
Um,
in a machine
ahead,
shop,
Cam.
because there's just so many ways of doing things. It's like learn everything you can from anywhere you can and run it through your own scenarios and see if it's going to help you or hurt you. And if you think it's going to help you or hurt you, run it through again and make sure you're right,
Mhm.
or have somebody else look it over with you.
It's
I mean,
funny.
I do it and it ends up sucking. So
That's right.
prepare for that too.
You never know. The best process for you is the one that gets you the best part that fits your quality requirements as efficiently as possible.
Mm-hmm.
That's basically the gist of it.
Without hurting
Uh,
something else.
right. It's funny, Cam, you mentioned, uh, like people aggravating you about how you go about a part. I actually have like the opposite feeling. I have that problem too, but where we're a little uh, old school with how we approach things. A lot of times I get people that are like, dude, why are you like the gun drill thing? You guys have heard me fuss about that. I don't know how many times. I had a video with a deep, it was like a 40 times D half-inch drill that I was drilling on a CNC lathe. I had 3 parts to do, man, but everybody was telling me, "Why did you not gun drill this part?" And I'm thinking, "Bro, for one, this machine is probably not, accurate enough to run a gun drill and not break it. 2, I don't think we're gonna spend $2,000 or whatever a half-inch gun drill would cost versus a $100, high-speed steel aircraft extension drill for 3 parts. And sorry, we're not, we might make 3 more of those parts in the next 2 years. It's not
Yeah.
worth it.
Yep.
And then like on the topic of work holding, uh, oh, a couple months ago, I think I shared a Instagram post of a part that we had to put a compound, excuse me, a hole in a part on a compound angle. And, we don't have a 5 axis. We've already covered that. uh, So, our best option could have been use a fourth axis and a fixture and all this other crap, and then still have to get the other angle somehow, or put the thing on a Bridgeport and tilt the head, nod the head. We ended up putting it on one of our 3 axis CNCs, set up I'm trying to remember. I think we set a sign plate on angle blocks to get the 2 angles that we needed and drill and tap the hole. It worked, but these folks I actually had, and I get it, I understand. I actually had a work holding company reach out to me when they saw that and offered, like, to demo me a way that their methods could, or their products could help me with that. And I get it. I love that. But, you know, sorry for 2 holes on these parts. And that's the first time I think in the 10 years I've worked here, we've had to do a compound angle hole on a CNC. No, we're not spending $10,000
Right.
on some kind of
That
fancy
yeah,
thing.
you guys should have ordered a 5-axis machine. I don't know what you were thinking there.
Well, I would love that, but it's not gonna happen. So
And that's just it, like I said, you get people that watch a 15, 30-second clip and they think they know everything about your shop,
exactly.
every capability you have, why you should do it this way or shouldn't do it that way. And they don't know. I mean, sometimes it's one part.
Yeah.
And I've watched people use a toe strap to clamp down a part for one part. Like
Yeah.
you gotta do what you gotta do to get it done.
Yeah.
What I love, I try not to let it bother me too much, and it really doesn't anymore because every comment that we get is engagement, you know? G do you know what? Leave the comments. I don't even care. Throw them out there. Give us all the, and great segue into, whatever. Leave us a comment if you enjoy this episode, whether you hate us or you like the way the boys are wearing their hats or whatever. Let us know because it helps.
Yep. I feel like we need you could, I don't know, a universal, some sort of somewhat universal flow chart to help decide when to invest in something for a job or whether to like just
Yep.
leave the job or whether to spend more time programming it or whatever. It's like for example, with the gun drill, is there a better way? Yes. Is it a more efficient way? Yes. Is the cost of the tooling going to save you enough time, like cycle time,
Mhm.
in order to still make money on the part? No. Like that drill's going to cost more than the parts themselves. You know what I mean?
Exactly.
Yeah.
We ought to do that. We ought to come up with like an Excel
Love to.
spreadsheet.
Yeah. Even like obviously you're not going to come up with something universal because this is machining and nothing's
Right.
universal, but um, something somewhat universal where like just to kind of help, just some sort of filter to help one keep yourself sane because it's so easy to go down a rabbit hole of like making fixtures and stuff like that. Like sometimes you get that idea in your head and you're like, no, I got to make a fixture. Like I need to do that. So some sort of something to keep you in check, but
That's right.
As long as you can make one, and as long as one of your flow charts leads to you're an idiot sandwich.
yes.
Well,
You wanna share who's gonna be on the next episode since we already got it scheduled?
yes. So we are going to be having another guest on our next episode. Joe from the Instagram account Random Fabrication. He's a really good guy, and he's another garage shop fella like Brad. But he's had one brother machine, and now he's got two of them. So it'd be really interesting talking to him about, how he grew from, getting started with a garage shop in California to now he's got two brothers.
He's never
That's
worked
pretty nice.
either.
Right.
Yeah, he never
Start from scratch.
and he still works his full-time job.
Yep.
This is a part-time venture for him.
Yeah. That wraps up this episode.
There you go.
Yeah. Well, yeah. Be sure to like, subscribe, comment, wherever you're listening to us. Any engagement is good engagement, like Pat said. Even if you think what we're saying is dumb, or if we're wrong, tell us we're wrong. If you know a better way, tell us a better way. I'm always here.
Oh, they'll tell us we're wrong.
Oh yeah.
They'll tell us we're wrong.
Yeah. Yeah. You don't have to ask somebody to do that. That's fun. All right. Well, as always, good talking with you guys.
Yep.
Hope you enjoyed. See y'all later.